Let's try to find out whether the given equation belongs to the homogeneous group, or is it the linear differential equation or the separable variable equation. So for that reason, for the first of all, you must check whether the equation is homogeneous or not. Now, in order to understand that the differential equation is homogeneous or not, the easiest thing is that find out the degree of each and every terms. Okay, so all if each and every term has the similar degrees, it means that it is the homogeneous equation. So let's try and look at the first equation. So here the power is 3, so degree is 3. Here 1 and 2, so it means here also the degree 3. Y has the degree 3, and then x square and y, it means both of them has the degree 3. So you have seen that each and every term has the degree 3. So it means that the first equation is homogeneous differential equation. Let's try the second equation. Now here the degree is 1. Over here the degree is 1. Over here the degree is x, and cosine x, of course it is not 1, and here sine x also is written. So it is not all, each and every term has the 1 degree, so it is not homogeneous. So this one is not homogeneous. Now similarly, in the last equation, e power x, y over x, so square root of 1 minus y square, it is also not in the form of homogeneous equation. So only the first equation is the homogeneous differential equation. Now after finding whether the equation is homogeneous or not, the second thing we have to see, is it the variable separable or not the variable separable. So the first equation, it's already homogeneous differential equation, so I'm not rewriting it and I'm not wasting my time on the first equation. Let's check the second equation. The second equation, write the equation in terms of dy and dx, means try to separate, first of all try to find out as write down as dy by dx. So if I can write it here, x dy by dx equals to x cosine x plus sine x, and this y, if I bring it down on the other side, it gives me minus y. Now have a look here. Over here, if I bring the dx on the other side, so over here I will get the dx here. So let me write, use another point. This gives me dx, and over here it is x dy. So if I want to convert all this one into dy by dx, so I can do it like this. Dy over this all goes down, so it will gives me x cosine x plus sine x minus y, and sine x minus y, and here equals to dx, and this x goes on the other side, so it becomes over x. So you can see that here I have dx over x, but here the dy is here, and here I have x cosine x, sine x, and y. If even I cannot separate them. If I cannot separate them, then it is definitely not the separable equation. So let's try another equation and try to write it in the separable form. Okay, so in this one, if I bring the dy here, or let's bring the dx on the other side. Let's bring the dx on the other side. So I will get y over x dy equals to minus e to the power x square root of 1 minus y square dx. Now I can bring the x over here. So I will get y dy equals to minus e to the power x 1 minus y square and here if I bring the x here, so it becomes x and here dx. Divide both sides by 1 minus y square. So now I can see that now this is the variable separable equation. The reason is all the y terms on the left hand side and all the x terms on the right hand side. So yes, this is the variable separable. Now let's try the last equation. What is this and how it is written? Now, linear differential equation. Okay, we have another type, linear differential equation, and in linear differential equation, we can write it as like dy by dx and plus, for example, p of x y equals to q of x. So this is one of the form in which linear differential equations can be represented. So here dy by dx means we are trying to differentiate the y with respect to x. And here you can see that there is another term of y which is multiplying with some function p of x. So p of x can be the function with respect to x or it can be any constant. And here also the q of x can also be any function or a function of x or any kind of the constant. So if the equation is written in this form, then it is said to be linear differential equation. Another type of the linear differential equation, it could be dx by dy plus p of y and here x equals to q of y. Now somewhere it is p and q is written and someone r and s is written, doesn't matter. Just see the forms that the function x is, you are differentiating something with respect to y, and here the x terms are written with the in the py form. So py is the function of the y and similarly qy is the function of y, or they can be any constants. So if the equation is written in this form, then it is said to be linear differential equation. Now let's try, because we have been left with the second equation. So I am writing it x dy by dx plus y equals to x cosine x plus sine x. So I'm trying to write it in the form of linear differential equation. For that reason, I'm dividing everything with by x. So I divide it and you can see that I got dy by dx plus 1 over xy and over here x cosine x plus sine x over x. So what have we noticed? That the first equation is the first term is dy by dx, the second term is 1 over x, that is also the function which is like p of x, and this whole thing is a kind of q of x. So yes, it is the linear differential equation of the first kind. Now, how can we differentiate using the integrating factor method? If any linear differential equation is written in the form of dy by dx plus p of x times y equals to q of x, then first of all try to find out the integrating factor. So how to find out the integrating factor? It is e to the power integral of p of x, here is the p of x times dx. After doing that, that all the differential equation will be multiplied by the integrating factor. Now, after multiplying by the integrating factor, the first two terms will be actually the product of the two functions. So we can write it as all the time d by dx of integrating factors times y. So that could be written as the product rule, and then we can write it equals to integrating factor of q of x, and then we will integrate it with respect to x. Okay, let's try to solve the first equation. by integrating factor method, and we will see that whether it is written in the form of linear differential equation or not. So for that reason, you can see that it is written as y prime, then it is written as 2y equals to x square e to the power 2x, and just compare it with the actual equation p of xy equals to q of x. So you can see easily that this equation is written in the form of linear differential equation. So let's try and use the integrating factor to solve this equation. How can we solve such equation? So for such equations, first of all, we have to find out the integrating factor. For integrating factor, we will take e to the power integral sign. And what is our integral factor? Integrating factor, this term, that is negative 2 dx. Now, integral of negative 2 is negative 2x. Now, so this is our integrating factor. Now, after that one, multiply the whole equation by the integrating factor. So I can write it as e to the power negative 2x equals minus 2, e to the power minus 2x equals to x e to the power minus 2x times x square e to the power 2x. After that, we have to write it in the form of integrating factor times y. So we will write here d by dx of integrating factor, that is e to the power minus 2x, and y equals to, now here e to the power minus 2x, here e to the power plus 2x. So if we have the same basis, we add the powers, that means minus 2x plus 2x. So you can cancel them. You will get e to the power zeros, which is equals to 1. So in the end, we have been left with only x square dx. Integrate both sides. So we will get e to the power negative 2x and y equals to x cube over 3 plus c. We have to find out the value of the y. So for that reason, divide both sides by e to the power minus 2x. So this is our final answer. That is y equals to 1 over e to the power minus 2x and then x cube over 3 plus c. That's all. So in order to apply any kind of the technique to solve this equation, the first thing is to recognize what kind of this equation is. So for that reason, just first of all start with the homogeneous differential equation, and for that purpose check the degree of all these equations. First of all, open the bracket. So once we open the bracket, we will get yx minus y times y gives me y square divided by x square. Now here you can see that y has one power, x has one power, together they have the 2 power, y square has the 2 degree and x square has the 2 degree. So all the degrees or the powers are same, so it means that our answer, our equation is said to be the homogeneous equation. So after doing that, we have to apply the technique of solving homogeneous equation. So for that reason, we always suppose that y equals to vx. Taking the derivative using the product rule, we will say f, that is y, g, that is x, that g prime, that is x prime, plus g, that is x, and f prime, that means v prime. Just to show you that your f here, you will use the product rule. So f is v and your g is x. So your f prime is your v prime and your g prime is 1, and we are using the product rule, that is fg prime plus gf prime. Now once we are done with this part, we have to replace the y and the y prime. So in place of y prime, I can write it as vx prime plus xv prime equals to y, that is vx. In the bracket we will write x minus y, that is vx, divided by x square. So now try to solve it, and before solving it, it is better if we open the brackets by using the distributive property. So Vx times x gives me Vx square minus V square x square dividing by x square. Now segregate the terms, means first of all write all the numerator terms separately with the denominator terms to solve it or to simplify it more clearly. So we can write it as Vx square over x square minus V square x square over x square. So x square cancel in both the terms, and we will be left with V minus V square. And on the left hand side it's Vx prime. X prime is 1. Okay, so I'm not writing the 1. It is x prime, which is equals to 1 plus xv prime. Now convert the v prime, means v prime is actually the dv by dx. So rather than writing v prime, write down dv by dx, and meanwhile bring this v on the other side. So you will get v minus v square. When this v goes on the other side, you will get negative v. Now minus v plus v will be cancelled out, and we will be left with x dv by dx equals to minus v square. Now try to separate them. Keep the dv by dx on the same side and bring the v square and the x on the other side, or write all the x terms on the right hand side, like bring this x dx on the other side. Let's have a look. So I will write here dx. Bring this x on the other side, so the x will go down in the denominator. And on the left hand side we will be left with dv, and this v square will go down, minus v square will go down, so over here. Now you can see that this is written in the form of variable separable equation. So here let's try to integrate them. Bring the v square on the top and minus at outside. So I will write minus outside. I will write it as v to the power minus 2 dv equals to integral of 1 over x dx. Now I know very well that integral of 1 over x is ln of x and plus c. And over here I will apply the power rule of integration. So I will add 1 in the power, which means v minus 2 plus 1 gives me minus 1. Whatever I add here, I have to write the same thing in the denominator. Now here negative 1 divided by negative 1 gives me positive 1, and if I bring v to the power negative 1 in the denominator, I will get 1 over v equals to ln of x plus c. Now v means y over x. V means, you can see, v means y over x. So from here I can clearly set that v equals to y over x. So replace v by y over x. So I can write it as 1 over y over x equals to ln of x plus c. And 1 over y over x can also be written as x over y. So let me erase this part somehow from here better. Let's erase from this part so that we can get some place to finalize our answer. So here I have 1 over y over x. It can be written as x over y equals to ln of x plus c. I want to find out the y, so y goes up and ln of x plus c will come in the denominator. So finally I will get ln of x plus c, x divided by ln of x plus c equals to y. So this is my final answer. Hope you understood how to solve such kind of equations. So have a look on this equation, and from the equation it is very clear that it is a kind of linear differential equation. The reason is that this equation is written in the form of y prime plus p of x equals to q of x. Or I can write this equation easily in this form. How can I write it? So let's see, the equation is xy prime plus 2y equals to e to the power x square. So if I divide all the terms by the x, then I will get e to y prime plus 2 over x y equals to e to the power x square over x. Now this equation is similar to the kind of the original form of this equation, linear differential equation. So after that, what is the first thing we do? We try to find out the integrating factor. So integrating factor is e to the power p of x dx, and in our case p of x is 2 over x. This is the p over x, if you can see. So here we will write 2 over x and dx. And I know that 1 over x, antiderivative of 1 over x dx is ln x. This is what I know. So for that reason, I can write that e to the power 2 ln of x is my integrating factor. And I know the property of ln, means if p ln of x is written, if I bring the power in according to the logarithmic property, I have anything written before the ln should go in the power of that base. So ln of x to the power p, I can write this thing. This is the property of logarithm. So in my case, I can write this 2 as the power of x. So I will get e to the power ln of x square. So what is the benefit of doing this is that e and ln are cancel out because they are the inverse of each other. So in the end, my integrating factor is x square. So after doing the first procedure, what I have to do, I have to multiply everything, all the terms of this equation by the integrating factor. So I will write y prime over here, just check, y prime plus 2 over xy times integrating factor, that is x square, equals to e to the power x square over x times integrating factor, that is x square. Now, after that, I know I can write these terms by the integrating. This is the product of integrating factor times y. So I can write it as d by dx of integrating factor, that is x square times y, equals to everything qx. Just write it down with times integrating factor. Now you can see here on the top x square is written and in the denominator x is written. So I can cancel out the square with the x. So I have been left with x e to the power x square. Now after doing this, integrate both sides. Integrate both sides. So on the left hand side, I will get x square y. And in order to integrate this, right hand side, I know that the derivative of x square is 2x. So I will ask myself, is the derivative written in the integration sign? Yes, it is written, only 2 is missing. So I know that if I have u prime e to the power au, for example, and du is written and a is missing, so I will write e to the power u 1 over a. So I can write it as 1 over 2, because 2 is missing, e to the power x square plus c. Now from here I can find out the value of the y by dividing the whole equation by x square. So I can write it as y equals to 1 over x square, y equals to 1 over x square, and the rest as it is, half e to the power x square plus c. That is my final answer. Now the question is to find out the explicit solution of the initial value problem. Okay, how can we solve these kind of the questions? So the first thing is find out whether it is homogeneous or the variable separable. So for me, I feel that this looks like the variable separable equation. The reason is that if I write the dy by y prime as dy by dx, so equals to t square over y 1 plus t cube, I can see very dt, sorry, y dt, because on the right hand side I have all these t. Now it is very clear that I bring the y over here and dt over here, so all the y values will be on one side and the t values will be on the other side. So this is a very clear variable separable example. Okay, so once I am done with this thing, all the variables are separated. I will integrate it with respect to their respective variables. Now y, it will gives me y square over 2, means I add 1 in the power. And I know one formula, the antiderivative of u prime over u du, it is equals to ln of u. But make sure that the derivative of denominator should be in the numerator. So focusing this part, if I focus on the denominator, number 1, the whole equation has no power, which means the power is 1. So it fulfills the demand of my ln formula. Now, what is the derivative of 1 plus t cube? Derivative of 1 is 0, but the derivative of t cube is 3t square. So I can clearly see that t square is in the numerator, only 3 is not there. So when something is not there, what do I write? I write 1 over 3 and then ln of u, that is 1 plus t cube plus c. Now I have to find out the y. Okay, but meanwhile I have been given the initial conditions, that is y of 0 equals to negative 2. Okay, so y of 0, it means the value of the y is negative 2. So I can write negative 2 whole square divided by 2 equals to 1 over 3 ln of. Now here the t is 0 because y of 0 equals to negative t. So it will be 1 plus 0 cube and plus c. Now negative 2 whole square over 2, it will gives me 2 equals to 1 over 3 ln of 1 plus 0 cube, it will be 0 plus c. So my c is equals to 2. Now over here I can write it as 1 over 3. I can write it as, now over here, okay, I can write it as y square over 2 equals to 1 over 3 ln of 1 plus t cube plus c is 2. Now multiply everything by the 2, means multiply here by the 2 and over here by the 2. So I will get, because I am trying to solve for the y square equals to 2 over 3, because 2 is multiplying by this also and this also. 2 over 3 ln of 1 plus t cube plus 4. Now taking the square root on both sides will gives me the y value, that is 2 by 3 ln of 1 plus t cube plus 4. So this is my final answer of this initial value problem. So again and again I am saying that whenever you get the first order differential equation, the first thing is that you have to recognize that which kind of equation is this. So again, looking at this equation, I can find out that this is the linear differential equation of the form y prime plus p of x y equals to q of x. And why I am saying this, let's check here. It is ty prime plus 4y equals to sine t over t cube. I can see here that here we have the t, so I can divide all the equations by the t. So I would get, on doing this, I will get y prime plus 4 over t times y equals to sine t over t to the power 4. Because a over b over c, it is equals to a over bc. So this b and c are multiplied by it with each other. So 3 and here 1, the powers are, bases are same. So we add the power. That's why it becomes t to the power 4. So you can see that here p of x is 4 over t and q of x is sine t over t to the power 4. So if it is linear differential equation of the first order, then I have to find out my integrating factor, which is e to the power of p of x dx. So e to the power, what is my p of x? That is 4 over t and dt. And I know that integral of 1 over t dt, it is ln of t. So 4 over t, I will get e to the power 4 ln of t. That's it. And I know that if any number or any coefficient is written before ln, that goes as a power of this base. So it will gives me e to the power ln of t to the power 4, and the benefit of this is that e and ln cancel out, and in the end I will be left with t to the power 4 as my final integrating factor. Now my next step is to multiply the whole equation, this equation, by the integrating factor. So I will get t to the power 4y prime plus 4 over t times t to the power of 4y equals to sine t over t to the power 4 times t to the power 4. Now, the benefit of this is that this is written as a product of integrating factor, that is t to the power 4 times y. And here I will write d by dx. Every time, whenever I finish multiplying my equation with the integrating factor, every time I have to write on this side, I will write it so that you never ever forget. On this side, I always write integrating factor times y. And over here, whatever left I write. So t power 4 cancel. That means sine to the power, sine t dt is left. Now integrate both sides. On integration, the left hand side will gives me t to the power 4 of y equals to, and the right hand side, the antiderivative of sine t is negative cosine t plus c. Now find out the value of y by dividing the whole equation by t to the power 4 on the right hand side. So that is our final answer. This is not cot t, this is cosine t. So this is my cosine t plus c, and that is all. So once you recognize the equation, the kind of the equation, the whole question becomes so easy. Okay, look at the equation of initial value problem. So look here and check what kind of equation it is. So y prime equals to t cube plus 1 over yt square minus t square. In a very first glance, I can say that this is not homogeneous equation. The reason is that all the degrees of each and every term is different. So now let's try how can I solve it. So next I will try as it is also not a kind of differential, the linear differential equation. Let's try to solve it and try to make it the variable separable method. So here t cube plus 1 as it is in the denominator, I can take t square common. So I will be left with y minus 1. So yes, if y prime can be written as dy by dx, then t equals to t cube plus 1 over t square is written. So this y minus 1 goes on the other side over here, and dx or means dt can go on the other side over here, and yes, it will become the variable separable equation. So I can write it as y minus 1 dy equals to t cube plus 1 over, this is t square and here dt. So now here try to integrate it. So antiderivative of y, by using the power rule, we add 1, so y square over 2. Antiderivative of 1 will be only y equals to, before solving this, it would be better if we segregate them. With each and every term of numerator, it is better to write the denominator, write it in the simplest form, and then take the antiderivative. So t cube over t square, this cancel, and here only one power is left, that is t, and bring the t to the power minus 2 on the top and write here dt. So here I will get here t, add 1 in the power, that is t square over 2. Add 1 in the power, I will get t to the power negative 1 over negative 1 plus c. So here on this side we will have y square over 2 minus y. Now it is the initial value problem which says that y of 1 equals to 0. It means in place of y I have to write the 0, and in place of t I have to write the 1 plus. So if I write here 1 to the power negative 1 over negative 1 plus c, so on this side I will get 0, and here I will get half minus, and here 1 over 1 minus 1 plus c, and if I write this in the calculator, half minus 1 gives me negative half, so it will be 0 equals to negative half plus c. If I bring the negative half on the other side, the sign will change and this will be equals to half. So in the end, over here I can write it as, finally, y square minus y square over 2 minus y equals to t square over 2. Bring the t down, so you will get negative 1 over t, and in place of c just write down half. So that is all you can leave over here, and then this is the final answer. Hope you understood these kind of miscellaneous questions, and if you have any query you can write in the comment box. Remember that your valuable comments means a lot for me. Thank you so much.